Hi folks, Dr. P here. This is Permutations and Combinations assignment question number 24. Consider a standard deck of 52 cards. How many different 4-card hands have at least one black card? So at least means that we would have in a 4-card hand, we would have 1 black, 2 black cards, 3 black cards, or 4 black cards. So the scenarios that we're looking at are the following. We have 1 black card, and if we have 1 black card, the 3 other cards will be red. Or we have 2 black cards, and if 2 of the cards are black, then the other 2 cards will be red. Or we have 3 black cards and 1 red card. And finally, we could also have a 4-card hand that only has black cards. We would have 4 black cards. Now, the order in which we get the cards doesn't matter. So it's a combination problem. And so for the first one here, in a 52 card, in a standard deck of 52 cards, we will have 26 black and 26 red cards. That means that for 1 black card, we're choosing 26 choose 1. In how many ways can we choose a black card if we have 26 available? And means multiplications. That's going to be times. And now we have 26 red cards to choose from, and we're choosing 3. So 26 choose 3. Or means plus. And then we continue like this and adjust the numbers for the different scenarios. So in the second scenario here, we are looking at 2 black cards. So it's going to be 26 choose 2 for the black cards, times we're looking at 2 red cards. So it's going to be 26 choose 2 as well. Plus, now we have 3 black cards. So it's 26 choose 3 times 26 choose 1. Okay, so this is a scenario where we have 3 black cards and 1 red card. And finally, we add to that the scenario with 4 black cards, which is going to be 26 choose 4. Now, if we determine calculate this on our calculator, so 26 choose 1 is 26 times 26 choose 3 is 2,600. 26 choose 2 is 325 times 26 choose 2, so that's the same thing, 325. 26 choose 3 is 2,600. 26 choose 1 is 26. And finally, 26 choose 4 is not 1,000, 14,950. Different ways. So we just evaluate this, and we are going to get 255,775 different ways, or different 4-card hands where we have at least 1 black card. Okay. So let's have a look at B here. At least 2 kings. So let's write down the scenarios again. We have 2 kings, so we can write 2 kings. And if we have 2 kings, that means we're going to have 2 cards that are not kings. So I'm going to write the complement to kings. This K prime means the complement to kings, which means anything but kings. So 2 kings and 2 other cards. Or we can have 3 kings and 1 other card, or we can have 4 kings. All right. So in a standard deck of 52 cards, we will have 4 kings, 1 of each suit. Okay, 2 of each color, so 2 black and 2 red. So over here, for the first one, number of ways we can choose 2 kings. Well, it's going to be 4, choose 2. Times the number of ways we can choose anything but a king. So if 4 of the cards are kings out of 52 cards, it means we have 48 cards that are not kings. That's going to be 48, choose 2. Plus. And now we're choosing 3 kings, so it's going to be 4, choose 3. And again, it's going to be 48 cards that are not kings, and we're choosing 1. 48, choose 1. And then finally, we're choosing 4 kings out of 4 kings, so it's going to be 4, choose 4. So if we evaluate this, 4 choose 2 is 6, times 48 choose 2 is 1,128, plus 4 choose 3 is 4, times 48 choose 1 is 48. And then 4 choose 4. There's only one way of choosing 4 kings out of 4 kings. If we evaluate this, we are going to get 6,961. And then finally, at most 2 clubs. So we're choosing, so the scenario here is we have 2 clubs and 2 cards that are not clubs, so they complement 2 clubs. So that's one scenario. Or we would have 1 club, and then we end up with 3 cards that are not clubs. Or the third scenario would be that we have 4 cards, none of them are clubs. Okay, so 2 clubs, there are 13 clubs. There are 13 clubs in a standard deck of 52 cards. So 13 cards per suit. So it's going to be 13, choose through 2. Times, how many cards are not clubs? Well, 52 minus 13, 39. So 39 of the cards in the deck are not clubs, and we're choosing 2 of them. 39, choose 2. Plus, and now it's going to be 13, choose 1. 39, choose 3. And then finally, we would have 4 cards that are not clubs. That's going to be 39, choose 4. 13, choose 2 is 78. 39, choose 2 is 741. 13, choose 1 is 13. 39, choose 3 is 9,139. And 39, choose 4 is 82,251. If we evaluate this, we are going to get 258,850 different 4-card hands that have at most 2 clubs. I hope that helps. Until next time, may the math be with you.